Okay, this is AP, AB, and BC Calculus. We are doing Unit 8, Section 7, which is volumes with cross sections. We're doing squares and rectangles, so let's go right to it. So we can use integration to find the volume of shapes. So the next several videos, we'll talk about different types of problems where we're using integration to find volumes of shapes. So basically, what's going to happen in most of the next several videos is we're going to be given some base area, like this blue area here, right? That's the square root of x. We're going to be given some base area in the two-dimensional xy plane. And we're going to be told that it has cross sections standing out of it in a particular shape. So in the image that I've drawn here, this particular shape is meant to be a square, right? Square cross sections, right? What I want you to do is I want you to think about these cross sections sort of like they're dishes in a dish rack. So hence the picture that I took from the interwebs of dishes in a dish rack. So they're the same shape plate. In this case, they are square plates, right? But they're different size plates, like you can kind of see on this dish rack. Again, it was very hard to find a picture that exactly encapsulated what I was going for, but that's kind of the gist. So there's a little teeny, infinitely, like super tiny square plate here, and then there's a slightly bigger square plate here, and there's a slightly bigger one here, and there's a slightly bigger one here, and they're all coming out of the board, right? They're coming out of this screen towards you right now. And there's infinite of them, and what they're doing is they're creating a shape. Like these square cross sections are creating a shape that comes out of the board. They're creating a 3D shape, all right? So that's what we're going to be doing in this video, and in the subsequent videos, just with different kinds of cross sections. In this particular video, we'll be focusing on squares and rectangles. So in problems where we have defined cross sections, basically what we need to do is we need to find the area. So if we go back up to the dishes for a sec, we need to find the area of one dish. Let's say this square dish that's somewhere in here, right? But it's not an area that's a number. It's an area that's in terms of x, right? So I find the area of this one dish, and then I use that area formula, and I add all the dishes. And the way we add the dishes is by integration. So what we're going to do is we're going to find the area of one of those cross-sectional dishes, right? And for right now, we're going to be talking about cross sections of the in the direction of the x-axis. We'll talk about cross section of y later. So most of the time, these areas that you're finding, these are very basic formulae, right? So we're talking the area of a square, which we're going to do in this video, right? The area of a square is that it has two sides. They're the same side, or I mean, it has four sides, but the two side lengths are the same. So the area of a square is side by side, side times side. The area of a rectangle, right? There's a base and a height. It's just base times height. These are going to tend to be formulae that you're very familiar with. They're not a whole bunch of crazy ones. I would say the hardest of them is the equilateral triangle, which we'll touch on in the next video. The trick here is that these values, s and b and h and r and whatever else we're using, are going to be defined by the functions in the problem. Like, they'll be defined in terms of x. Once we find the area of that one plate in terms of either x or y, depending on which direction we're doing this, we just add up all the areas by integration, and that's the plan. So here's how we're going to walk through some examples. The best way to get good at this volume stuff is lots and lots of examples, and we have volume videos for pretty much the rest of this. The rest of Unit 8 is all areas areas that are integrated to get volumes. That's what we're doing from here on out. So that's 8.7 through 8.12, and then 8.13 is something different for BC folks. But that's a lot of these videos, so we're just going to practice a lot. The region bounded by the curve f of x equals the square root of x, the x-axis, and the line x equals 4 is the base of a solid whose cross sections perpendicular to the x-axis are squares. Find the volume of the solid. So here's what's happening. I should start by drawing my dish perpendicular to the x-axis, because that matters. It would be a very different dish rack if the dishes went the other way. And I'm going to try and draw a square coming out of the board. And it's not pretty, and it doesn't have to be pretty, but this is my one dish, okay? So when I look at this dish, it has a side length that goes from this curve down to this bottom value. The side length of this dish is the top curve, which is the square root of x, minus the bottom y value. It's this y value minus this y value, which in this case is 0. So the side length of this thing is root x. The side length of the square right here would be the square root of whatever this number is. The side length at 1 would be a square root of 1. The side length at 2 would be a square root of 2. The side length anywhere along this curve is the square root of x. That means that my area in terms of x is side squared, which would be root x quantity squared, or just x. Once I know that's the formula for the area, the first dish starts at 0, the last dish ends at 4, so the volume of this thing is the integral from 0 to 4 of all my dishes, right? Well, the area of a dish was just x, right? This was the area, so just x with respect to x. So I'm going to get that this is an x squared over 2 from 0 to 4. The volume of this thing is going to be 16 over 2 minus 0 over 2, so I'm going to get 8. And there's no units, so I don't write units, so the volume is 8. So again, our job is to find the area in terms of x, so this area in terms of x is what has to go in here. If we were integrating dishes going the other way with respect to y, if the dishes were perpendicular to the y-axis, then everything would have to be in terms of y, and we'll get to that later. We're not there yet. All right, moving on. Okay, so the region bound by the curve f of x equals x squared, the x-axis, and the line x equals 2 is the base of a solid whose cross-sections perpendicular to the x-axis are squares. Find the volume of the solid. So again, this is my dish rack. The dishes are perpendicular to the x-axis. So somewhere in here, we're going to pick a random spot and we're going to draw a square in 3-dimension coming off of this thing. So the side length of the square is the top curve minus the bottom curve, right? So the side length of this square is the top, which in this case is x squared, minus the bottom curve, which in this case is y equals 0, right? So top y value minus bottom y value, or just x squared. Since the area of the square is side squared, that's going to be an x squared squared, or an x to the 4th. So my volume is going to be the integral from 0 to 2, because the first plate is at 0 and the last plate is at 2, of whatever that a of x is. So in this case, that's going to be the integral of x to the 4th. I'm going to get that this volume is x to the 5th over 5, evaluated from 0 to 2, which is 32 fifths minus 0, or just 32 fifths. So the hardest part of this problem, really every one of these problems, the hardest part is figuring out what a of x is. If you can figure out that a of x, it's not that bad of a problem. All right, let's keep moving. Okay, so now I have a little bit more complicated problem. All right, so the region bounded by the curves y equals x squared plus 1, that's definitely this one because it's a parabola, the line y equals x, and the lines x equals 0 and x equals 4 is the base of a solid whose cross-sections, again perpendicular to the x-axis, because we're always perpendicular to the x-axis right now, are rectangles with a height twice that of their base. So somewhere in here, I pick a random spot to draw my dish. Whatever this dish is, it has a base, and it has a height that is double the base, right? Whatever this base width is, the height is twice that of the base, right? So I look at this base, and I realize that I can write this base as the top curve minus the bottom curve. So this base is the top curve, right, which is x squared plus 1, top y value, minus the bottom y value, which is just x, right? So top y value minus bottom y value. So I get that the base is x squared, I'm probably going to write it in standard form, minus x plus 1. I know that the height is twice the base, right? So basically the area of a rectangle is base times height, but in this instance, the height is twice the base, so that's base times 2 base, or just 2b squared. That means that I can find my area in terms of x to be 2 base squared. Now, if I have a calculator, this is going to be a lot easier. Without a calculator, this is less fun, but we'll walk through just in case. So that means that the volume I'm looking for is the integral from the starting dish to the final dish, so from 0 to 2, of this area, which is 2x squared minus x plus 1 quantity squared with respect to x. Now, if it's a calculator section, great. If it's a calculator section, typey, typey, type, get your answer. If it's not a calculator section, so we could type that just to see what would happen, right? If we want to do this, we would do math 9, right? We would do 2, and then in parentheses, x squared minus x plus 1, quantity squared, right? Comma, with respect to x from 0 to 2, and we'd get an answer, and that's fine, okay? And we can math frac it if we want, because most of the time there. So we'd get that this is, and we don't even need an approximate because it's a terminating decimal, it's an 8.8 or a 44 over 5. Now that's fine, right? That's great, you can do that. If it's not a calculator, right, if it's non-calc, then this is one of those problems that gets a bit tedious, right? Most of the time, I'm going to be honest and say that the volume questions you see on the AP are on a calculator question. Most of the time, what they care about is this. They care about the setup. They don't care about, they're more than happy to have you type to get the answer. So I'm going to say that it is unlikely, because this is a fairly tedious problem, so it's unlikely, the ones we saw as example 1 and T1, those might show up as a multiple choice that on a non-calculator section because they're fairly nice integration. But if it were a non-calculator section, they're unlikely to give you one that requires you to distribute this. We're going to do it, right? So we're going to distribute this. I'm going to get this to, I'm going to walk you through it, but it's unlikely. So when I distribute, I'm going to get an x to the fourth minus an x cubed plus an x squared. Then I'm going to distribute this guy next. I'm going to get a minus x cubed, a plus x squared, and a minus x. And then I'm going to distribute this guy and get a plus x squared and a minus x and a plus 1. So if I clean this up, just the algebra part, I get 2x to the fourth. This is a negative 2, so it would be a negative 4x cubed. This is a 3x squared, so that's going to be a 6x squared. A negative 2x becomes a negative 4x when I multiply by 2 plus 2. I'm going to get this. This is what's inside that integrand, right? And actually, it would have been smarter if I were a smarter human. I would pull the 2 out in front. So let's actually do that, because that would have been the smarter plan. So we're going to keep the 2 out in front of the integrand for a second, just FOIL the inside, because that's going to make our whole life a lot better, because you can factor out a constant multiple. So I would get that this thing, so my integrand is going to look like this. It's going to be a 2, integral from 0 to 2 of x to the fourth minus 2x cubed plus 3x squared minus 2x plus 1 with respect to x. So if I had to integrate this by hand, the 2 is just going to chill in front. I'm going to get an x to the fifth over 5 minus a 2 fourths, so I can make that a 1/2 x to the fourth, plus an x cubed minus an x squared plus an x. From 0 to 2, I'm going to go ahead and make this a 1/2 because that would be easier. So now when I plug in, there's a 2 just chilling in front of all of this. When I plug in 2, I'm going to get 32 fifths minus, this is a 1/2 times a 16, so that'll be an 8, right? Plus an 8 minus a 4 plus a 2. And then conveniently, when I plug in the second bound, at least it's all a bunch of 0, which is nice. So I'm going to get this as a 2. I have 32 fifths. The 8's conveniently sum to 0, and I get a minus 2, right? That's a minus 2, so that'd be minus 10 fifths. Hey, there you go. So I get a 2 times the 22 fifths, which is totally the 44 fifths we got when I went with the calculator first. So that's exciting. Yay, 44 fifths. So again, the point I want to make is this seems really tedious doing it by hand. You're probably not going to be doing a long problem like that by hand. It is reasonable to say that you might do one like this by hand. That was a very simple integral, and might do one like this by hand. It's not likely you're going to see one that requires foiling out and distributing a trinomial squared, but it's possible. All right, so the big thing I need you to take away from this is how to set up the expression. So the region bounded by the curves y equals 2 minus x squared and y equals negative x squared is the base of a solid whose cross sections perpendicular to the x-axis are rectangles with a height that is half that of their base. So what we're saying is, going in this direction, there is a rectangle such that whatever this base is, the height is 1/2 that base, right? And so those are my rectangles. So my job is to find the area of one of those dishes, right? So I noticed that the area of this thing should be base times height, which in this case is base times 1/2 base, or 1/2 base squared, right? I know that this base is top curve minus bottom curve. So the base should be top minus bottom. The top curve is definitely the parabola, so 2 minus x squared. The bottom curve is definitely the negative x. So I think I get that this is a negative x squared plus an x plus a 2. So my area in terms of x is going to be 1/2 this thing squared. Yet again, I'm going to point out that this is likely a calculator question. So what the AP needs to see is the AP needs to see that you get that the volume is the integral from where it starts, which is the first dish at -1 to the last dish at 2, so -1 to 2, of 1/2 negative x squared plus x plus 2 quantity squared with respect to x. And then honestly, this is probably a calculator section and you're getting an answer. So you're probably just going to go ahead and go second enter, because we did this already. I'm going to change the 2 to a 0.5 because that's the 1/2, right? I'm going to insert a negative in front of that x squared. I'm going to make it a plus x, and I'm going to make it a plus 2, and it's squared, and my integral is from -1 to 2. So let's double check that's right. I get a 0.5, a negative x squared plus x plus 2 quantity squared with respect to x from -1 to 2. I hit enter. Oh, wait. So hit go to, it just means you're missing a parenthesis somewhere. Oh, sorry. I did -1 and forgot to shift it over. So it's -1 to 2. Enter. All right. So I get 4.05, so I don't even need the approximate because that's definitely a terminating decimal. So I get 4.05, or if you want to math frac it, I get 81 over 20, right? So you can do the same thing I did in the last one, and I can walk you through it, but realistically, it is likely a calculator problem, right? So this is probably, so this is likely a calc problem, just because it's so tedious if it's not a calculator problem. It's not a terrible problem, but it's just so tedious without a calculator. You would have to FOIL this whole thing out. It would be somewhat miserable. Rather than do that again, because I think that does eat up a lot of video time, and I know some of you could choose to skip that, but I think it's been a long video section in general. I'm not going to FOIL it out for you, but if you chose to do it, you would have to distribute this. So if you chose to do it, I would yank the 1/2 out in front of the integral, and then I would FOIL all this stuff out, probably in a separate space where I have some work, right? So I would distribute all this, and then you'd have to integrate the same way. So I'm going to say that you'd have to do this like we did in example 2, okay? So I'm more than happy to walk through that if you want me to, but I feel like it's probably tedious. Oh, then again, you can fast forward. You know what? I'm going to walk through it. If you really don't want to see me do it, just skip to when I do example 3. So when I distribute this, right, I'm going to get that this is a positive x to the 4th, right, a minus x cubed, and a minus 2x squared. This guy's done. When I distribute the x, I'm going to get a negative x cubed, a positive x squared, and a plus 2x. This guy's done. When I distribute the 2, I'm going to get a negative 2x squared, a plus 2x, and a plus 4, right? So this is going to be an x to the 4th minus a 2x cubed minus a 3x squared plus a 4x plus a 4. So I'm going to get that this volume is a 1/2 in front of, we're integrating from -1 to 2, x to the 4th minus 2x to the 3rd minus 3x squared plus 4x plus 4 with respect to x. When I integrate, again, I just leave that 1/2 chilling. So I'm going to get an x to the 5th over 5 minus a 2/4, so we'll just make that a 1/2 because it happened last time too. 2/4 x to the 4th minus an x cubed plus a 2x squared plus a 4x. And unfortunately, neither of our bounds are 0, which is kind of a bummer. So this 1/2 is going to be in front. When I plug in 2, I'm going to get 32/5 minus 16 over 2, so that's minus 8, right? Minus another 8, plus another 8, plus another 8. Oh, that's convenient. Yay. Okay. So that's the first thing. And then when I plug in the -1, I'm going to get a -1/5. I'm going to get a -1/2. I'm going to get a +1, a +2, and a -4, right? So I get this 1/2. Here I only have the 32/5. That's the only thing that survived. All the 8s knocked each other out, right? I'm going to get that this, so I probably would combine these together to get a -1 first because that's a 3 and a -4, right? So I'm going to get a +1/5, a +1/2, and then a +1, right? And now it's just a matter of getting a common denominator, which should be 10 because of the half and the 5, right? So I get this 1/2 in front. So this is 64. Actually, you'd probably make this a 33, right? So you'd probably get 66 tenths, right? 66 tenths. And then when you make this into tenths, it would be 5 tenths. And when you make this into tenths, it's 10 tenths, right? So I end up getting that this is a 1/2 times, this is a 71, so that's an 81, right, over 10, right? So I end up getting that this is an 81 over 20, and I feel like that rings a bell. Hey, look, it's totally the right answer. That's exciting. Yay. Okay, so you probably all skipped this, and I was doing this for myself, but it's fine. All right, so E3. So the difference here is now we're perpendicular to the y-axis. And the big hint that that's happening is that things are in terms of y instead of in terms of x. So again, it's all about the setup. You're probably using your calculator to integrate, okay? It's all about the setup. So I say, all right, so now these are perpendicular to the y-axis and they're squares. So this, perpendicular to the y-axis, so my dishes are going this way now. Different dish rack, right, going this way. So the side length of the square, just like we saw when we were finding area before, if something is horizontal, we use right minus left. So the side length of this square is going to be the line, because this is very much a line and this is very much a parabola, right? So it's very clear that this is the curvy thing, is going to be right minus the left. So once I know that that's the side, right? And actually, I'm going to show you a cool trick with your calculator in a sec if you don't want to clean this up, right? So once I know that that's the side length, right, my area of a square is side squared. So honestly, my area could just be written as 2y minus this quantity squared if it's a calculator section. That means that my volume is going to be the integral from the first dish, which is going to be at y is -1, to the last dish, which is at y is 3. So the integral from -1 to 3 of this area, which is just 2y minus y squared minus 3 whole quantity squared with respect to y. So here's the reason that's kind of cool. If you had bothered to put this in as, like, let's say y1 and y2, you could just use y1 and y2 here. So if you know it's a calculator section and you don't need to write out the math, which would be lovely, right? Remember, we're cheating and using x's because we know that we can't use y as the independent variable in our calculator, right? So I do this, I quit out. I look at this and say, oh, this is the thing, so this was the thing that I called y1 in my calculator, this is the thing I called y2, right? So I could say this is math 9, right? And then in parentheses, I have y1, y2. y2, it wouldn't actually matter because you're squaring it, so in this instance it wouldn't matter because it would come out positive anyway. y2 minus y1, quantity squared, with respect to x from -1 to 2, and then I didn't even have to bother to worry about simplifying stuff, and I get that this is a 30.6, right? Or if I math frac it, I get that this is a 153/5. And again, it's not approximate because that was a terminating decimal that ended before the 3 places, so it's not an approximate answer. If you had to do this by hand, it would be the same tedious thing we've seen in the other examples. It would just be with respect to y. So I'm not going to do it again. I've done it on several different examples. I'm not going to do it again. This is what you'd get if you put it in a calculator. So again, this is likely on a calculator section because it's tedious. If it's not on a calculator section, sometimes they say set up but don't integrate this. So sometimes a multiple choice will actually say set this up but don't integrate it, just show me what I need to do in order to find the volume. That's another really common question. I think it's, so it's either on a calc section or they might say something like set up but don't integrate. So they'll say, what is this value, or like, what is the integral that you need in order to find this volume, but they won't ask you to find it. That's another common way they do it if something's tedious. All right, so let's do one more, and I think this is our last one. So the region bounded by these curves, so x equals the square root of y and x equals -y, this is definitely the square root one, right? Because this is definitely curvy and this is definitely the line, for the record, right? And the line y equals 2 is the base of a solid whose cross-section perpendicular to the y-axis. So again, the dishes are going this way, perpendicular to the y-axis, are squares. So you have a square coming off this way, right? Square looks like this. So you need to find the side length of that square. Remember, when we have a horizontal line, that side length is going to be right minus left, right? And I think on the last one I might have written top minus bottom by accident. Oh, I didn't write either. This would be right minus left, right? Because it's a horizontal line. So right minus left. And so that's going to be the right curve, which is root y, minus the left curve, which is a -y. If you want to write this as root y plus y, that would be fine. Like, that's kind of totally sensible here, right? That means that the area, since it's a square, is side squared. The area is going to look like this. So the volume is going to be the integral from the first plate to the last plate, so from 0 to 2, right, of this thing, quantity squared, with respect to y. And again, it's really likely that you're not being asked to do that by hand, right? It's very, very likely that you're going to be doing that on a calculator. If you had to do it by hand, you'd have to FOIL it out, as we've seen in previous examples. I'm not going to right now because it's been a long video already. So, so we're doing root x, right, plus x, quantity squared, right? So I make sure there's parentheses around the entire thing, comma, with respect to x from 0 to 2, right? And we hit enter. And this time it's an approximate answer, which makes sense because there's going to be a square root of 2 involved in this somewhere. So I get this. And that time it's approximate because I definitely had to round or truncate, okay? So that's the gist. The next video is going to be talking about a different kind of cross-sectional area, but it's the same topic, just a different cross-section.